Hello, today we shall try and understand the Comber timing diagram. We'll see how these various parts of the Comber are arranged or rather operate in a sequence. So, for this operation to be perfect one after the other in a particular sequence that is decided, there needs to be some kind of reference point, and this is done by this help of an index wheel over here, which is similar to the crankshaft that is there on the loom, which tells you the timing of each operation that happens on the loom. So something similar is there over here, which is known as the index wheel. The combing operation is a series of operations that must be carried out in a particular sequence without any interference with each other. So this is the first condition, and for this the index wheel helps to set the machine elements relative to their operation sequences. So by looking at the numbers, we can and setting them accordingly, it will help us to set these operations relative to each other in their particular required sequence. The index wheel is fixed on the cylinder shaft. The wheel circumference is divided into, that is this circumference, it's a wheel which is divided into 40 equal divisions, and the readings can be read out against a pointer fixed on the machine frame. There's a pointer on the machine frame which is seen over here, and as this index wheel rotates along with the cylinder shaft, whatever number comes against the pointer, it can be read, and during setting this particular numbers would help us in setting those operations to begin and end at those particular timings as per the numbers that are seen on this particular index wheel. So let us, with this basic background of how these numbers are actually set, let us see how these operations are divided, and how the sequences are set relative to each other. So first let us begin with the nipper operation or the nipper movement. The entire nipper assembly, as we know, should be moving forward and backward. It has got a swing in the forward direction and the backward direction. So this is the index timing that is shown in the form of a graph over here. You can see there are 40 divisions that are shown on the index wheel. It is shown on this particular x-axis, and we shall see how this nipper movement is um, is allotted a particular timing for its forward and backward swing. So combing has to be carried out when the nipper assembly is farthest from the detaching roller. So as if you remember the sequence, we know that there is a cylinder which is in between the nipper assembly and the detaching roller, and the cylinder action requires some space before the combed fringe is delivered to the detaching roller. So if that space is required, what should happen ideally is that the cylinder action should be happening, or the combing has to be carried out when the nipper assembly is the farthest, or rather it is far away from the detaching roller as much as possible. So with this thing in mind, this is how the nipper assembly, as we know the working we have seen earlier. Then this entire nipper assembly is moved by this nipper shaft, which is making it move, swing forward and backward. So as you can see now, at this particular moment here, the cylinder is in action. As you can see, the half lap is pointing upwards, and you can see that the nipper assembly is as far as possible in the at the back, and there is enough space between the detaching roller and the nipper assembly so that proper combing action can take place here. So this should be the position. So the nipper assembly moves forward and backward, um, and more time is to be allotted for the forward movement. Now we cannot say that forward and backward we give the same time and things are all right, but here there's an observation that more time needs to be allotted for the forward movement than the backward movement, and this is because we need the forward movement of the nipper assembly to be slow. And why exactly do we want it to be slow is that um, as the nipper assembly is moving forward, along with the combed fringe that is being freshly combed by the cylinder to pass it on to the detaching roller, During that time, we have to see the fringe is very, very delicate, and because of the movement, whatever air, surrounding air movement is there, it should not buckle the combed fringe from the front at the leading edge of the fibers, and that is why it has to be as slow as possible so that they do not buckle. um, and that is what is being said: the slow movement of the nipper assembly in the forward direction therefore shall not buckle the combed fringe moving towards the detaching roller due to the air drag, and not adversely affect the piecing quality. So definitely we must keep the forward movement as slower than the backward movement. So a ratio is selected which is 60 to 40. For forward it is more, and backward in this ratio this particular time is chosen. So now if there are 40 divisions for this entire movement, for the forward and backward movement of this particular nipper assembly, then we can allocate 0.6, that is 60% for a forward, that is 24 divisions, and remaining 16 for the backward journey. So we have, let us say that we begin with the nipper assembly. We could have allotted any number, since this is the first movement that we are fixing. So we could have allotted maybe 8 onwards or 12 onwards, but we prefer to start from 0. So 0 to 24 is allotted for the forward swing, and from 24 to 40, that is remaining 16 divisions, the nipper assembly would be moving backward. So this is our base now, on which all the other movements, whether it is cylinder, detaching roller, feed, everything will be fixed based on the fixing of this particular movement of the nipper assembly. So having fixed this movement, let us move further. The forward journey can begin at any index, as I just mentioned, and all other operations will be set relative to the nipper movement timing. So now next we see is the cylinder operation. So the cylinder combing is allotted 1/4 of the cycle time. Now 1/4 of 40 means 10 index numbers, and therefore only 1/4 part of the circumference, we must have observed that 1/4 part of the circumference of the cylinder is covered by needles, and which is also has got a name. It is called as a half lap. If we need to increase the surface area of the needles, we need to increase the diameter of the cylinder, but we need to increase the surface area without any increase in the cylinder weight. We must remember that this particular cylinder is rotating at a very high speed, and we should not, as far as possible, try to increase the cylinder weight. But if at all at the same time we need a larger surface area of the needles for better combing, then we must find some other way to do it, and that is done in the modern combers by changing the shape of the cylinders. As we can see, this is a modified shape. This will not increase the weight of the entire cylinder, but at the same time it has allowed for a larger comb area, which they claim is 130 degrees over here. So this is how it is worked out. The combing by cylinder must start when the nippers are farthest from the detaching roller, so that there is sufficient space for combing. That is backward to forward journey of the nipper assembly. That means when it is farthest away from the detaching roller, means the nipper is at the backward most position, and from there onwards it would start the forward journey. So during this time, this is the ideal time for the combing operation to start. Therefore, the combing operation starts by just 5 index numbers before the completion of the backward swing. So the backward swing is from 24 to 40 we saw. At 40 it would be at the backwardmost position. So before that 5 index numbers we are subtracting, and so at this 35 index number we can start the combing by cylinder very safely, because once as it begins to to comb at 35, during that time the nipper assembly would have moved still further back up to 40, and from this 35 to 40 and beyond this, total 10 index numbers we need to allot to cylinder combing. So when you say 10 from 35 onwards, 5 will lead to 40, and from 40 to say 5, again starting from 0, we get total 10 index numbers. So therefore the cylinder operates from 35 to 5 index numbers. So having seen this, let us put this in the form of the graph that we have done earlier. So forward swing was from 0 to 24 and 24 to 40 was a backward swing. Combing starts 5 index numbers just before the backward swing ends, which is at 35. So combing will start at 35 and it will move right through 40, and again the index would be 0 at that time, from 0 to 5. So this would be the area for the cylinder to operate. So now, having seen the cylinder operation, let us go to the nipper opening and closing. Now we must also arrange for nipper opening and closing, when it should open, when it should close, and how much time we can allot for each operation, that is opening and closing. So the nipper must be closed for the entire, now we must understand the conditions. We want the nippers to be closed for the entire duration of the combing operation. That is this entire 10 divisions from 35 to 5. We must keep the nippers closed, otherwise all the fibers would be taken away into the knot. And in addition to this 10 divisions, we give another 6 safety, for safety's sake, so that we are 100% sure that the nippers are closed during the entire combing operation and we do not lose any good fibers in oil. So we give a plus 6 for safety, and so we now have 16 divisions for this operation to happen. Um, so therefore time available, so this closing time should be 16 divisions. So the remaining time, that is 40 minus 16, that is 24 index divisions we would be having for this entire operation to happen, that is opening and closing should happen within these 24 divisions, because 16 divisions we have fixed for entirely for that nippers to be closed. So more, now here also we have to give more time for opening than closing. Since we want to avoid any abrupt movements of this opening and closing, we give opening 60% of the time and 40% for the closing. So if we take 60% of 24 divisions, we get 14.4 divisions, and similarly we get 9.6 divisions for closing. Now we need to understand, if we get 14.4 divisions for the opening of the nippers, so when exactly it should begin, so that we can find the time of starting of closing. So now starting time of nippers will only be after the cylinder combing is complete, that is after index number 5. So we have seen that this entire combing operation should happen with nippers being closed. So the opening will happen only after this. So when the cylinder operation ends, that is at 5, and we give plus 5 divisions allowance for safety. So so the nipper will start opening only at 10 index number, and it will, as we have decided, we are giving 14.4 divisions for this entire openings, gradual opening to take place. So it will take 14.4 divisions to open, so it will be completely open, as it is gradually opening, and completely open at around 24.4, that is you can say 24 index number. So let us now add this element to our earlier graph. So we have already put in nipper movement, we have put combing timing. Now we put in the the nipper opening, which starts at 10 and completely open at 24. So now let us go to the nipper closing in the similar manner. Since it has opened up to 24, from 24 onwards it will start closing, and we have allocated as per this ratio in our earlier slide 9.6 divisions for the entire gradual closing of the nippers. So at 24 the nippers will start closing and continue for the next 9.6 divisions, which comes to around 33.6. So you can say at around 34. So it will be completely closed, and gradually it will start closing at 24 and complete its closing at 34. And this 34 is very important, because immediately after 34 the next cylinder combing would begin, and at that time, at any cost, we need the nippers to be completely closed. So if this nippers surely close at 34, we have one division time before the cylinder starts its combing at 35. So if the closing of nipper is quick, if we are able to quickly close the nippers, then the nipper closing may even takes place a little bit earlier, around 33, well before the beginning of combing. So it depends on our kind of mechanism that we have used for opening and closing. So if it is possible to close it earlier, it is still better. So we can close it at around 33 maybe, so that safely combing can start at 35. So putting this or representing this on the graph, we see that nipper will close from 24 and completely close at around 34. So we just draw this, and this is the next step where we have added nipper opening and closing. So we come to the feed roller movement. The feed roller needs to move intermittently. So what are the timings we should fix on that? So the condition that we must remember before we fix up these timings. So let us look at them. During lap feed, the nipper must be open. That's the first condition. Nipper must be open whenever the lap is being fed, and feeding should end before cylinder combing begins. So the feeding should end definitely before 35. So lap feed can be during the forward swing of the nipper assembly, from 10 to 24. So around 13 to 24 to be sure, as the nippers are open enough throughout. The as we saw in our earlier graph or the discussion, that nipper would be open in this particular index timings. So we can safely have the feeding from around say 30 to 24. We are sure that the nippers are completely open. In case of a forward feed, if we are looking at forward feed, we should look at this particular timing. So in case of forward feed, it can start from 13 right up to 24, when we are sure nippers are completely open, and we are also sure that it is not interfering anywhere with the combing. We can see over here this entire gap is empty, and that means the combing has started at 35 but ended at 5, which is well before, or it is the feeding operation will complete within this time before the next combing cycle begins. So, and during the backward swing, if we are looking at the backward feed, then in that case it which will happen from 24 to 40, because this is the backward feed um, timing. But again, the same two conditions apply, that the nippers must be completely open, and it should happen it should be completed well before combing starts. So safely we can say that from 25 to maybe 32, we can be sure that the nippers are still open, and definitely at 32 we are sure that combing has not started. So our backward swing can be from 25 to 32. So having seen this, let us look at the detaching roller rotation and its operation. Before that, let us see once again how they are placed relative to each other. This is the entire nipper assembly, which carries the bottom nipper, top nipper, as well as the feed roller. And this is the lap sheet. And this is the detaching roller, which would have a forward and backward rotating movement to bring back the fringe a little bit before the next tuft is superimposed on this to give you a continuous sliver. And this would be the detaching, that is the distance between the nipper and the detaching roller whenever this nipper assembly is very close or the closest to the detaching roller. So uh, with this understanding, let us see how this forward and backward direction rotation for this detaching roller are fixed, the timings that are allotted to it. So detaching roller rotates in the forward and backward direction, and around 50% time is allotted to the detaching roller rotation. That is, out of entire 40 divisions, we are allotting 20 divisions to this particular operation, and both the rotations are equally divided. That is 10 divisions for forward and 10 divisions for backward rotation. So the detaching roller must rotate only during the forward movement of the nipper assembly. That is, when the nippers are moving forward, um, it starts at 0 and up to 24. So during this time, the detaching roller must rotate forward. Also, detaching must start only after the combing operation is over. Therefore, it cannot be between 35 to 5. So we must these are the two conditions for the detaching ruler timing fixing over here. So therefore, the window left for the detaching ruler rotation is between 5. That means after the completion of the cylinder operation, and from 5 right up to 24, because during this time the nipper assembly would be moving forward as per our condition. So up to 24, we have around 19 divisions with us, where we can give the detaching roller its rotation. So backward rotation of the detaching roller, so the rotation will begin at around say 7. 7 is because we want to be safe about the completion of the combing operation. So the backward rotation will start at 7 and go right up to say 10 divisions. As we had decided, we are giving 10 divisions for each forward and backward. So around ends at 17. It will start at 7 and end at 17, which is 7 plus 10 divisions. After this, the detaching roller will start moving forward, that is from 17 onwards. And again, we have 10 divisions which we have allotted, so up to 27, and 17 and goes on up to 27. Since beyond 24 also, we had said that nipper assembly should be moving forward, but in this case, even if we go up to 27, there is no harm, because the detaching roller forward rotation does not interfere with any other movement or any other operation that is happening during this time. This we can easily see from the graph here. So the backward movement is from 7 to 17, as we have mentioned here, and from 17 to, even if it goes right up to 27 beyond 24, it is not interfering anywhere with any of the combing operation that is happening. So we can safely go up to 27 for the forward movement. So now, having seen all this, let us see the how the top comb timings are fixed. Now we know that the top comb should penetrate the fringe only after detachment processes begin. This is because if it enters earlier, the front end of the combed fringe will get buckled, because if the top comb is already there in the area, then the nipper assembly, as it is moving forward, it will be faced with a sort of obstacle due to the top comb which is already present there in between it and the detaching roller. So the fringe might get buckled as they have not yet reached the detaching roller, and therefore the entry of the top comb will interfere with the piecing process and also the quality of the sliver. So we must see that top comb timings are perfectly fixed. So only after the front ends of the combed fringe is gripped by the detaching roller, only after that the top comb should enter. That is 1 or 2 divisions after the detaching roller starts rotating forward. We saw in the earlier slide that it starts rotating forward at around 17, and therefore it can, this top comb entry can happen safely 1 or 2 divisions later, that is around 18 or even 19. So top comb must remain in action till the time that the detaching roller is going on, but must end before the cylinder operation begins. This is for sure, because the cylinder will start its operation at 35. So in any situation, any condition, under any condition, the top comb operation must stop before 35. So safely we can say that we stop it at 31. So top comb entry will take place at around 18, and it will remain till 31. At 31 it will be withdrawn. So with this, we come to the end of the timing diagram, and thank you.